Hello, good morning. Now I am myself Gyandev Kumar, my cohort named Dynamo. Now I am going to explain our first code in this program. Given the wrong code and we have to answer correct the code. In this situation, here we need to the AND operator, and in AND operator we can operate the both side. In if first statement is false, then it will also execute the second statement, but we can use or end function, end function. Then we can, if first statement is false, then it can't be able to execute second operation. So it is the best option to power of the super power end. And now I am going to explain our second module program, that is six number. In this program is a happy, and the calculate function calculation of sum square is an. Here we can take a sum as 0, and we are using for the num of the 0. So count the digit and module by 10, and sum of the explanation is the happy function working by the using two pointers. Using two pointers, there are two pointers, slow and fast, which both start input number. The slow pointer move on a step at the time, while the fast pointer move to a step at a second time. So in the module here we can use math follower num function, and we can return the function as a scene of the return value. And let's take a new function, and while we are creating the scene of the calculation of number, and we will increment the n plus 1. So and we can execute our code on that process. And here we can take a slow as a n and fast as a also n. So we execute our code using do while loop on that statement. And now I am going to explain our third program, that one 11.1. In this program we have to write the program. First we are creating here function, and then we take the length of the string, and we have to check the length of the string. And we are using while function for the left of the right, and using math follow left to plus right, and in divided by 2. If n mid greater than mid plus 1, the right mid equal to 2, and the less mind of left one mind, and to the out of the mistakes of the program. In the step of the modulation that can be executed on the math of the program. Here we are calculated the index of the array using mid value, and if we change the left of the mid, then it will change the m plus 1 return left. And otherwise we can't use on that type of the explanation, because in here we can use mid in the our dividing the module into the array into two part, that we need to find the mid value. So we can execute our code in the better manner of the our explanation, and that target will be dependent upon the explanation. Now I am going to explain our fourth one program, that is using of use to traditional approach and optimal approach. And which one is the why we use why the optimal approach is considered mm, better in the optimal approach. In traditional approach, we are using a function and array. In array, we are using hash set function, and here hash set function we are using to set the new array of the length. So hash set function add arr into equal to I, and again we have to check the second iteration of the I. And if the integer is not is hash set, it is the missing integer. So if the missing integer is I should return I. Otherwise, if no integer is missing, return n plus 1, return 0. Optimal solution in this could be taking iterate the array on the function of the I into n, and while I is greater than array of I and n greater than the out of array. So we can here we can take as a AND operator, and again we check the array of n greater than, and again we check the array of I minus 1, and then we using the for loop for the iterate again in once again we target the if array I is not equal to I plus 1, then return I plus 1 and return n plus 1. Here we can say that the optimal approach is considered better because it achieves the same task of finding the missing number with a low space complexity overpower and compared to overpower and perform the task in a single pass through the array. The traditional approach, on the other hand, required additional memory for the hash set and make to pass through the array, making it less efficiency in the term of both time and space complexity. In the here in traditional approach, we can take as a function class solution, and here we let as a temporary variable and store the array of the length, and we can store the zero length of array, and we can set the value of array, and we can again using the temp variable to set the array of the length. And optimal solution, we are using the return to join the array of the string. So we can say that the optimal approach is considered better because it achieves the same task of removing duplicate character with a significantly lower time complexity overpower and compared to overpower n square, and more efficient, more use overpower k compared to overpower n. The use of set data structure simplify the process and improve performance. And now here we are taking the chunk array in group array size. Let temp equal to array and result equal to array. Here again we are using for loop for the iterating the array and checking the a size is not equal to size minus 1, then temp push array a, otherwise else temp push array a and result push temp, and temp array is equal to empty string. If the temp length is not equal to 0, result push temp return result. So again here we check the if condition to if the temporary variable length is not equal to 0, the result push the temporary variable. And optimal solution const array is equal to empty, and let's take I equal to 0. Here we can using while loop for the iterating the array, and we can push our value into the new array, and we can take as a I plus size 1 and I equal to size plus 1, so return the new array. In this provider, the optimized approach is considered better because it achieves the same task of chunking the array with a simple and more concise code using the slice method. It has the same time complexity as the traditional approach, but is more reliable and strength forward. The use of built-in array method like slice make the code more maintainability and reduce the risk of array. And now I am going to explain our code in worst case and best case of the scenario. In that case, I am explaining both worst case and the best case and the worst case. The worst case for the word frame salary function is when the input string is very large and contain a large number of words that need to replace. In the case of the function will have to create a large number of replacement word and iterate over the input single multiple time. And best case for the best frame story function when the input string is a very small and content only a few words that need to be replaced. In this case, the function will have create only a small number of replacement word and iterate over the input string on the length. Here we can count and word to split using a split function to replace the word into the thousands of mm, equal to and iterate replace word into push adjective. Again, we use the const output let I equal to 0 word of length replace I replace l dot replace word dot length equal to adjective output push element else output push word join the word to convert the story const story equal to output join return the story. Const str equal to an adjective noun verb or of the adjective noun repeat 10,000. Console time worst frame story. Const result worst frame story input. Const time is equal to worst frame story. Here we can take as a value in term of array, and we can split our word array into the split of string, um, and it is the best case of worst case of our code. And now I am going to explain the best case of our program. Here we are using the function, and inside the function we are using a split function const replace word equal to elegant, and replace the word in the input with pairs of speech, and the I equal to length of the storage, and the input of the input string is a very large millions or and billions. That time the input string contain a large number of words to be replaced. In the creating of large number of replacement, it will be take a long time to require the memory, so we can use the push function to push our data into the strength of the small memory. In case create only a small number of replacement word, iterate over the input string only a few mm, time to find the replacement of the word and that need to be replaced. So here you can see the worst case result is much longer than the best case result. This is because the worst case input is much large content more what it need to replace our the code. So we can't able to judge our code in the better manner to target our achieve the statement. Thank you.